Good evening to all of you.
Good evening, sir.
Good evening, Bharati.
Good evening, sir.
Good evening, Adi, Siti. Good evening.
Good evening, sir.
Good evening. Good evening. So yesterday we have discussed the Bayard-Savart law. We have discussed magnetic field direction, and we have seen the analogy between the Bayard-Savart law and Coulomb's law. Many have missed yesterday class, so you can take notes and you can read once. You will understand nothing different I discussed or nothing, not any difficult part. Only that Bayard-Savart expression, vector form, scalar form, analogy, Bayard-Savart and Coulomb's law, and direction of magnetic field. Three rules I told. One is
Right hand thumb rule.
yeah, thumb rule for straight wire, right hand thumb rule for circular wire, and right hand palm rule. That I will say now also. How many of you missed classes here yesterday? Yesterday, how many of you missed class? Okay, so whatever may be the number, take notes after class. If you want notes, you stay. I will show the screen here. You can take that screenshot. You can take and you can read once. If any thing you feel difficult, we will discuss that. Now today we'll start with the application part of Ampere's circular law. See, this is the magnetism important chapter. In magnetism, I told this chapter, if you focus properly, other two chapters are completely related with this. So all basic things, magnetic force, magnetic field, direction, application, okay, these if you are clear with this, then coming to chapters magnetism and matter and EMI, you will know. Not difficult. Okay, so I have what I discussed yesterday, that I will tell, or now you can take a screenshot also, those who have missed. From here I started Bayard-Savart law. Bayard-Savart law is used to find the magnetic field due to current carrying conductor there. Take a screenshot. Bayard-Savart law, those who missed class yesterday can take a screenshot now. Took care this one?
Yes, sir.
Mute everybody, mute. Mute. Vector form of Bayard-Savart law. Vector form. Completed.
Sir.
What are the important points in Bayard-Savart law? Two important points. One, that angle dependent, and one, direction. After this, I have discussed Analogy between coulombs and Biot-Savart law. Analogy. This you can take a screenshot. Completed up to 6. Then see that up to 11. 11 analogies we have discussed in Coulomb's law and Biot-Savart law. Completed everybody up to this analogy part? Hello?
Yes.
Then direction of magnetic field. Direction of magnetic field, these are rules, okay? Direction of magnetic field, first rule is right hand thumb rule for straight wire. Your thumb should be in the direction of current, then curling finger curling finger coming towards you or away from you. If it is towards you, so magnetic field outward. If it is away from you, so it is what? Inward. And fingers, this dotted line is the magnetic field lines here. Tangent to the magnetic field lines will give magnetic field direction. Out of 3 rule, any one rule you have to use. This right hand thumb rule if you don't want, so palm rule you use. Yeah, this right hand thumb rule for circular wire. Curl your finger in the direction of current, then normal thumb will give direction of magnetic field. Okay, so here thumb will come outward, here thumb will go inward, magnetic field direction you will get. This is right hand thumb rule. And last one is right hand palm rule. Palm rule means thumb in the direction of current, finger towards the point where you want to calculate magnetic field, the normal to the palm will give the magnetic field direction. Clear here? Completed everyone up to this? Yes or no? Completed here?
Yes, sir.
Yes, sir.
So this is the magnetic field direction. Once again I will tell, this rule only you have to use. Right hand palm rule, only one rule you fix in your book. Right hand palm rule, right hand palm rule. Thumb in the direction of current, finger towards the point where you want to calculate magnetic field. The normal to the palm will give you magnetic field direction. Magnetic field direction. Some example we will take. After that you will do few. So only this rule you have to know. Everybody will see that. Tell me, suppose this is the current carrying conductor. Now if I ask you at point P and at point Q, tell me at P point what is the direction of magnetic field?
Outward.
Use palm rule. Thumb in the direction of current. Thumb in the direction of current. Finger towards the point P. See, thumb in the direction of current. Finger towards the point P. The normal to the palm. Tell me outward or inward?
Outward.
Point is outward. Not only at P point. Every point this side here, magnetic field direction will be outward. Tell me at Q point what is the magnetic field direction?
Inward.
Thumb in the direction of current. You see, finger towards the point Q, then normal to the palm will be inward. So here everywhere magnetic field direction is inward. Clear? Everybody understand?
Yes, sir.
Now tell me if I reverse this current direction. If I reverse and if I ask here M and here N, tell me magnetic field direction at M and N.
M inward, N outward. Inward and N outward.
So you know that thumb in the direction of current, then finger towards the M point. So tell me normal to the palm inward or outward? Normal to the palm inward upon the M point here. So it will be inward. Tell me at N point, thumb in the direction of current, finger towards the N point. Normal to the palm is outward.
Outward.
Understanding everyone? And you can also check here. We have reversed the current direction here. So see magnetic field direction also reverse. Here dot, now here cross. Here cross, here we come dot. Clear? Everybody clear with this?
Yes, sir.
And tell me what are the magnetic field at these points? At these points, what is the magnetic field? If here I ask you x and y, so magnetic field at x is what? 0. Magnetic field at y is what? 0. Why 0? Why 0? Because point lies
Along
on
the
the
axis.
Sin
axis.
theta.
And yeah, point lies on the axis theta 0 or theta 180. This I am not telling, Bayard telling this, that if theta 0 or theta 180, magnetic field is 0. This is we discussed here yesterday. Heading right down, applications of Ampere circular law. Sorry, applications of Bayard-Savart law. Just now I discussed for TR amperes, so ampere only in mind. Write down applications of Bayard-Savart law. Applications of Bayard-Savart law. Very important one. You'll find that 50% of the chapter now, more than this year, in magnetic field. You must know how to calculate the magnetic field with direction and magnitude both. Okay. Now 3 applications we will discuss. In that first application is what? Write down. First application A, that magnetic field due to, write down, B due to magnetic field, B due to current carrying circular loop, current carrying circular loop, B due to current carrying circular loop at its center, at its center, at its center, when it carries current I, when it carries current I and having radius capital R, carries current I and having radius capital R, radius capital R. Clear?
Yes, sir.
Yes.
Now don't write anything, just see. Bayard-Savart law we have to use and we have to derive this expression. This is not in board exam, but result is very important. Result you have to focus. Result with derivation, if you understand, it will be easy to remember. Suppose one circular current carrying conductor is there, loop is there, conductor or loop. At the center you have to find the magnetic field at the center O point. This carries current I, any direction, clock, anti-clock, your wish. Suppose here I consider this is the current. Now you remember for calculating the, for applying the Bayard-Savart law, you know one element you will select, that is ideal. Due to this ideal, r distance away, angle theta, you will write magnetic field. And what magnetic field writing? dB, which is mu naught by 4 pi ideal sine theta by r square. So here also one element we will select, current element, anywhere in this loop element we will select. Suppose I select one element here. This is my current element here. See, complete gone. Carries current I is the center of current element we are selecting. Like this one element we selected. Ideal element. Very small element is there. I am making here big to make you understand. Ideal. Now from ideal r distance away, here we are calculating variable. Here in this at center we are calculating. Can you tell me from current element to center what is the distance here? From current element to center, what is the distance? Tell me. Radius or not? Yes or no? Radius or not?
Yes, sir.
Radius.
Yes.
You know here radius vector r vector, because here r vector you remember. Can anybody tell me what is the angle between radius vector and the current element? You all tell me. You all tell me. Current element. If current element is very small, so can we treat that as a straight line here? In circular arc, you remember, if distance, if arc length is very less, so can we treat as a straight line here? Yes or no?
Yes, sir.
So here very small element is there. This is nothing but as a straight line, as a tangent. Now tell me, between tangent and normal, you know, if any line pass to center, it will act as a normal. So tell me how much angle is there here? 90 degree or
90
not?
degrees.
So first thing we got here, see, theta value 90. Theta 90. Now, due to a small element ideal, I want magnetic field dB. What is dB? I will write here. Mu naught by 4 pi I into dl sine 90 divided by r square. Which r? Tell me. Small r or capital R here? Here small r or capital R?
Capital R.
Capital R.
R here radius here. Achha, now I got here, see, mu naught by 4 pi I into dl divided by r square. Now you all tell me, this magnetic field we calculated only due to one element dl. Tell me. If I take one more element here, like this ideal element, one more element I will take ideal element, one more element take ideal element. So like this you tell me how many infinite element I can make or not? Yes or no? Infinite element
Yes,
I
sir.
will make or not? Due to every element same value we will get or not? Tell me. Due to every current
Same
element ideal same value we will get here. Now tell me direction. Due to all the current element, tell me magnetic field direction same or different? Tell me magnetic field, which rule you will use here? Any rule you use, tell me what is the magnetic field direction? Due to all the current element, tell me magnetic field direction inward or not? Yes or no? Curl your finger in the
Yes.
direction of current. Magnetic field inward. Tell me all magnetic field will add or not? All direction same, so will add or
Yes,
not? Tell me. So if
Yes.
all will add, I want total magnetic field. Tell me how to do. How to
Integration.
Integration.
integration. Now I want net magnetic field at O. Net magnetic field I want at center here. What I will do? I will integrate this integral dV here. Integral dV. You know dV is what? Mu naught by 4 pi. Tell me mu naught by 4 pi constant or not? Can we take this outside? Can we take this outside? I dl by r square. Tell me radius also constant or not? Can we take radius outside? Can we take radius outside here? 4 pi r square. Tell me same current flowing in complete loop or not? Is current changing? Is current changing in the loop?
No,
Tell me.
sir.
Same current. So I also I can take outside. Tell me. You know dl is variable here. dl integral dl. Tell me now everybody, dl element if you add here total, so tell me what you will get. What you will get dl if you add here?
Else.
L,
2
L you
pi
will
R.
get.
2 pi R.
What is L? L is the length of the circular wire. What is the length of circular wire? Circumference of L will be 2 pi r or not? Yes or no?
Yes,
Understanding
sir. Yes.
everybody? Integral dl will be L, and what is L? It is 2 pi r. So you see I got here mu naught I divided by 4 pi into r square. Integral dl become what? 2 pi r. And I got here magnetic field. Tell me 2 pi can we cancel with this here? 2 pi to 1 r
Yes,
can
sir.
cancel. What value we got? Tell me. Mu naught I divided by 2r. Mu naught I divided by 2r magnetic field at the center of the circular current carrying loop is what? Mu naught I by 2r. This derivation you must understand, then other questions you can answer. Now tell me, if I ask you, semicircular wire is there. We don't have circular wire, we have only semicircular wire. If semicircular wire is there, tell me what is the length by integrating, what you will get? What length of semicircular bar? Tell me.
IR, sir.
Yeah. If you tell me semicircular bar is there, length will be pi r. Tell me if length pi r, then what expression I will get here? If pi r,
U not I by 4 or
4r we will get. Mu naught I by 4r will get. Tell me if quadrant is there. Instead of semicircle, if quadrant is there, what will get? Tell me.
IR by 2.
Quadrant is there.
Mu
Pi r by 2. Pi r by 2, then what magnetic field I will get? Tell me. Length
Mu
will
naught I by
8 or
8 R.
mu naught I by 8. Tell me, as length changes, magnetic field expression also changes or not? Yes or no?
Yes,
So
yes, sir.
you can understand if you know the derivation. Okay, we will discuss all the points, that quadrant how much for, if any arc is there, 60-degree angle there, 30-degree angle is there, 20-degree angle is there, how to find that also we discuss. So this is here we have written magnetic field. I repeat that magnetic field we got at the center BO, or you write B center, we got here mu naught I divided by 2r. This is the magnitude form here, magnitude. Tell me direction form, what I will write? What is the direction of magnetic field? Magnetic field direction, what will write here?
Inward.
Inward. So here B center, or we will write mu naught I divided by 2r, and it is what? Inward. Inward means cross. Clear? Everybody understood this? How many of you understood derivation? Derivation, how many of you understood mu naught I by 2r? Now fix in your brain, circular bar means magnetic field at the center, mu naught I by 2r. And proof, if anybody asks, proof also you can do. And now by using this, we will derive the other expression also. First note it down, everyone. Completed.
completed, sir.
Write down important points. Write down important points. Okay, so more focus you have to, that in the that these basic things you have to focus more at point. Okay. After that you'll find that now I am going to complete in TR batch that chapter. Very nicely they are answering. Anything asking, they are answering. So they have attended each and everything. Now for you also telling the same, those who have missed Bharat Savarta, you can, you have taken a screenshot, you can read once, it will be clear to you. Now important point to see. First thing we got that magnetic field at the center, we got mu naught I divided by 2r. This one wire is there, circular wire is there, circular loop is there, carry current I, so magnetic field we get at center mu naught I by 2r. Radius of this is r. Tell me how many turns we have taken in this loop here? How many turns we have taken for this? For one turn.
One turn, sir.
See, for one turn. If nothing mentioned means you have to know this is one turn only, or here one in this loop one turn we have taken. Now listen to me. Suppose two turn. One loop we having one, now loop having two turn here. Okay, one one turn and one more turn. Same direction current they carry. Same direction current they carry, but two turns are there now. Now tell me, due to one turn we got mu naught I by 2r. Due to second turn, how much magnetic field will get at the center here?
Mu naught by
mu naught I by
Mu
R.
naught I by 2r or not? Yes or no? Due to one turn, like see, first turn, second turn, one over the other they placed there, one over the other. They carry current in same direction. They must carry current in same direction because you know that they all are in series. See how that helix shape or that loop, you all have seen that coil how they form. If you stretch, you know it will be straight line or not. If you stretch, it will be a wire or not, right? Straight wire. Here you are like this. Same current in series, you know current should be same. So if here instead of this one loop, if, in one turn, if two turns are there, how much magnetic field will get? Tell me. 2 mu naught I by 2r or not? Yes or no? Double
Yes,
will get or not? Tell me.
Yes,
Three
sir.
turns are there, how much will get? Due to three turns, how much will get?
3 mu naught I by 2R.
Four turns are there, how much will get? Four turns are there, how much will get? Tell me.
4 mu naught I by 2R.
Tell me if n turns are there, how much will get? If n turns are there, how much
N
will
mu
get?
naught I by
N
2R.
mu naught I by 2. Now many students got confused in this because the expression will be written like this: mu naught Ni by 2R. So they will think current increased n times. By number of turn increasing means current increasing. Current not increasing. Magnetic field increasing. Due to one we got magnetic field x. Due to two 2x. Due to 3x. Due to n we will get nx. So magnetic field increasing because they all having the same direction. So for one turn we getting this. For n turns, I will write for n turns. N turns I will make diagram also, then you will get the clarity here. See one turn this. Here like this here, one over the other. Okay, these are not that different. One over the other. One over the other like this. All are like this only here, and all carry current in what? All carry current in same direction current they carry. So at center, how much magnetic field will get? New magnetic field will be what at center? BO dash, that will be n times of what? N times of mu naught I divided by
2R.
so which will be mu naught. You can write here mu naught Ni by 2r. Note it down this everyone. First important point this. For one turn this one, for n turn it will be mu naught Ni by 2.
Completed, sir.
One second, sir.
Write fast. Completed now.
Sir, little up, sir. Only for the diagram. Thank you, sir. Completed, sir.
See second point everybody. Second point that due to circular loop we calculated, due to circular loop, you know, magnetic field we calculated at center, that mu naught I divided by 2r. Because tell me length, how much we got here? Length value here. Length we got 2 pi r or not? Yes or no?
Yes, sir.
Length
Yes,
of this.
sir. 2 pi r, sir.
Now I am asking you, if here we having semi-circular wire here, we having now semi-circular wire. Semi-circular wire. This carry current I. This is the center point here O. Is having radius r. Means for semi-circular wire. Semi-circular wire. Tell me what is the length of semicircular wire? Length will become how much? Tell me. Pi r or not. If pi r, then what magnetic field will get? Tell me at center. What magnetic field we getting?
Mu naught I
Just
by R.
half we are getting or
Mu
not?
naught I
Sir,
by
screen is struck, sir.
Screen is stuck. Hello.
Yes, sir.
Yes, sir. Voice is also breaking.
Breaking, huh? Now okay.
Sir.
Write something.
Huh?
Sir, it is there in the screen which you wrote before, sir. It is not moving, sir.
I will 1 minute try. Am I audible now? Hello.
Yes, sir. Now it is.
Yes, sir.
Okay, sir.
Screen visible now?
Yes, sir.
Yes,
It's
sir.
visible, sir.
Clearly visible?
Clear, sir.
So you tell me, for circular wire we got this one. See, for circular wire we got magnetic field this one here. For semicircular wire what magnetic field will get? Tell me. For semicircular wire what magnetic field we will get? U naught I divided by 4 R. Huh? U naught I by 4. Just half of this. Because why half of this? Oh yeah.
Now audible, sir.
Now okay, huh?
Yes, sir.
Yes,
Yes,
So
sir.
tell me, magnetic field due to semicircular wire will become what? Half of the circular wire. Why? Because length become half. Length become half, so magnetic field become half here. Mu naught I divided by 4R. This you have to know. Now tell me, if I ask you quadrant. First, see, after that you write here. Huh? Same here, if I ask you for quadrant. Uh, for quadrant, tell me length will be how much for quadrant? For quadrant length how
L
much?
by 2R.
Length will be what? Pi by 2 into R. This is the quadrant here.
Sir,
This is
screen is
quadrant.
not visible, sir.
Sir, it's visible.
Sir, visible, sir.
Visible only. Visible only.
To you not visible, Masik Roshan, you check your network. This here quadrant. See, for quadrant, that tell me what is the magnetic field due to quadrant here? Hello. If radius here R,
Mu naught
Mu
I
naught
by
I by
8
8
R.
R.
just
Mu
half
naught
of
I
the
by 8 R.
yeah, half of the semicircle. So mu naught I. First note it down. This everyone. Do this.
Road, sir.
Okay. What is happening here? Completed everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Completed, sir.
You see these are the quadrant, semicircle, circle. If suppose any arc they ask, 30-degree arc, 40-degree arc, 50-degree arc, any that arc they ask, then how you calculate magnetic? So you see everyone, for arc, suppose we having here any arc which makes an angle theta at the center. See this only. Now in complete here, this formula if you remember, then for semicircular or for any that you can derive from this. Okay. Suppose this makes an angle theta. Radius is what for this, that is r. Can anybody tell me in arc length, this is arc length, this radius, this theta, how they related? Tell me. L or theta, how they related? Can you tell me?
Theta is equal to
Theta is equal to L and R.
Anna, can we write L is equal to r theta? Yes or no?
Yes, sir.
L equal to r theta. Na? You see what you did here. For circular, you tell me. For circular, theta become how much? Tell me 2 pi r not. For circular,
Yes,
theta
sir.
2 pi. For semicircular, theta pi. For quadrant, theta 2 pi by 2. Now for any arc, you tell me theta is, angle is theta here. So theta into arc is, r is what? The arc length. Now this length if you put in original expression, now in original expression derivation, you see, tell me instead of dl what you will write, instead of l what you will write, 2 pi r or theta, instead of 2 pi r what you will write, r theta. So you see mu naught I divided by 4 pi r square. This you can understand if derivation, that's why I told you that focus on derivation part. Magnetic field I will write at O point is mu naught I divided by 4 pi r square integral dl. Integral dl will be mu naught I into L divided by 4 pi r square. And L value is what? R theta. L value is r theta. So mu naught I divided by 4 pi r square. Instead of L here, you will write r theta. R theta. Now see 1r cancelled out. What value you will get? Tell me. What value you will get here?
Mu naught I divided by 4 pi r.
Mu naught I theta divided by 4 pi
4
r.
pi r.
A little bit we will arrange this. Okay. Can I write this mu naught I divided by 4 pi r? Can I break like this? 2r into 2 theta? Yes or no? Sorry. 2r into 2 pi
Yes.
can be break like this? 2r into
Yes.
2 pi.
Yes, sir.
And numerator what I can write? Tell me theta. This
Theta.
formula is now finally telling you that BO due to any arc magnetic field at the center is 2 mu naught I by 2r theta divided by 2 pi. This you remember, any expression you can derive it. Now first see, after that you write here. Tell me if I put here theta is 2 pi, I will get circular or not? Yes or no? If
Yes,
theta
sir.
2 pi, then tell me circular or not? How much you will get due to circular? Tell me. How much it
Mu
will due to
naught I by
circular?
2R.
I divided by circular. Tell me if theta equal to pi, what you will get? Theta equal to pi, what you will get?
Mu naught I by 4R.
4r or not? Pi cancel. So you will get here mu naught I by 4r semicircular. Put theta equal to pi by 2, how much you will get? Theta
Mu
pi by
naught
2,
I by 8R.
mu naught I divided by 8r. So here it will be a quadrant. It will be quadrant. This formula is very, very important. For any arc they ask, 30 degree, 40 degree, 60 degree, any arc they ask, you can answer the magnetic field at the center. How many of you understood this expression? Clear this derivation. If otherwise you have to remember the formula. Here with derivation told you that how this expression come. Now in complete whatever we discussed in this circular competitive exam, only one formula telling you to remember. That is mu naught I by 2r theta divided by 2 pi. Note it down this. Arc, magnetic field due to arc. What about direction? Tell me direction. Anybody? Direction is what? Inward, outward,
Inward.
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 Hold your finger in the direction of current. That you see, thumb is downward. Or right hand palm rule you can use. Current in the direction of current, thumb. Then see, finger towards O. So normal to the palm is inward. Clear?
Yes, sir. Clear, sir.
So magnetic field we calculated due to circular loop, semicircular loop, quadrant, any arc at the center.
Sir, can you show that proof, sir?
Fast, right, Radhisri? Completed everybody now?
Completed, sir.
Only length here substituted r theta, and this is original proof that starting which you have written same. Now questions based on this we will discuss if you have understood. So we'll see 4-5 questions we will see based on this. Question number 1. Question number 1. This question. This is the center O, radius R. This carry current I. Tell me what is the magnetic field at O point here?
Mu naught I by 4R.
Very nice. Some are answering. Everybody should answer now. Magnetic field at O point. Huh?
You not I.
I by 4.
Okay. See everyone. This question I will tell once. Those who are not getting. What we do always starting. First you do like this. Complete loop. Complete this. You divide into sections. You see, this is a straight wire. This is semicircular. This is also straight. I will write net magnetic field at O point. Now because you know magnetic field vector addition superposition we have to do vector addition. Tell me due to 1 and 3 what is the magnetic field at O point here?
Zeros.
Due to
Zero.
1 and 3. Why 0? Tell me. Why 0?
It is
Why
along the
0?
axis.
On the axis or axis
Very good.
magnetic.
Point lies on the axis of the wire. See this you know very well. Due to semicircular, tell me what is the magnetic field? Due to semicircular magnetic
Mu
field.
naught I by 4. Mu naught I by 4.
Right.
I by 4 R.
Now tell me what is the direction if I ask you? What about direction? This direction.
Inward. Sir, inward.
Everybody
Inward,
should
sir.
know direction is what here. So our answer you see mu naught I by 4R. Direction is inward.
Inward.
Easy or difficult? Tell me. Easy or difficult?
Easy, sir.
How?
Easy.
Direction. Half without direction you getting, so it is up 50% correct. Direction also you have to do. First note it down this. Then I am giving you now 4 questions. Fast you work out. You told that EG, na EG. We'll see that EG. Mute, Ambi. This carry current I. What is the magnetic field at O point? Radius of this is R. BO.
Mu naught I by 6 R.
Divya, properly check.
3 mu naught I by 8 or
3 mu naught I
3
by
mu naught
8
I
or
by 16 or
16 or
8 or
8 hours, sir.
8 or. This you are doing mistake nonsense fellow. This simple one. Uh,
Sir,
wait. All parts calculate. We'll discuss one by one.
sir,
Yes. Tell me.
sir, if current direction reversed, we should not add them, no, sir, because one will be outward and another will be inward.
Then we have to subtract. Yeah.
Subtract.
Yeah. Five questions only discussing, not more. Fast answer me.
third one 0.
Third one 0, sir.
0.
Fourth
Okay.
one, it
0
is
sir.
mu
Fourth
naught
one,
I by R.
mu naught I by 8.
Mu naught I by R.
Check properly.
Sir, fourth one don't know to do, sir.
Mu naught I by 8 or sir.
Mu naught
Don't-
I by 8 or
Don't know to do, for that only given not to do.
Fourth
Huh?
one.
Try, then only you will know not that how to do. By seeing, if you tell that don't know to do, then how you will do?
No, sir, I tried, but I had doubts, sir. Like, we must add or like that, sir.
Direction if same, add. If the action opposite, then subtract.
Okay, sir, now what? Sir.
I by 8 or
Okay. Try everyone. One more minute giving you, then we'll discuss one by one. In package, so many
Yes.
questions given. Anna, you try magnet here. If you work out 4, 5 also, they are all questions you will do, and you will feel easy also. Tried everyone? All parts tried, yeah?
1 minute, sir.
Okay. Atmika, tried all parts.
Yes, sir.
Okay, see everyone, now I will discuss. Second question first, we'll see. Second question. Tell me second question, how much angle it makes at the center? Angle, can you tell me angle how much? This is 90, this is 90, this is 90.
275.
270 means 3 pi by 2 or not? Yes or no? Pi by 2, pi by 2, pi by 2. And you know magnetic field is what? Mu naught I divided by 2 or theta divided by 2 pi. What is theta here? Tell me. Theta is 3 pi by 2 divided by 2 pi. Pi cancel. How much you will get answer? 3 mu naught I by 2 into 2 into 2, it will be 8r. And direction you know very well, it will be inward r. So 3 mu naught I by 8r. Clear? Everybody understood? Second question.
Yes, sir. Yes, sir.
Third question, see everyone now. Third question, that see due to inner loop and outer loop, okay? First you see only direction. Due to inner one, tell me direction is what? Curl your finger in the direction of current. Inner one, tell me direction is inward or outward?
Inward, sir.
Inward direction. Due to inner one, inward. Due to outer one, tell me.
Outward.
Outer one, outward. Due to this, it is dot. You can write here. BO vector is because of B1 and B2. B1 and B2. Now B1 on a direction we got, this is cross, this is dot. So if you take dot as a plus, then cross as a minus. If you take cross as a plus, then dot as a minus. Generally we take dot as a, sometimes answer they will give in terms of dot cross only. Sometimes answer they will give in terms of plus minus. So accordingly that options you will see, and then you will that choose which one is correct here. Okay, B1. So B1 you will write, you know, this here mu naught I divided by 2r. Direction is what? Cross. B2. B2 you see what you will write? Mu naught I divided by mu naught into what is I here? I is 2I or not? Hello. Current here 2I divided by 2. And what about radius here? Radius here 2r, not r. Radius here 2r. So 2 cancelled out. And this is what? Dot. So you will get here, see, mu naught I by 2r cross and mu naught I divided by 2r dot. Either this way you will get the answer, or if you take 1 plus 1 minus, so it will cancel out there. Means if you take this 2r as cross as a minus, so dot as a plus. So plus mu naught I by 2r, so it will be 0. And options, okay, according to options you will say. Understood? Third one. Third, everybody understood third part?
Yes, sir.
Now, fourth one. Tell me what is the magnetic field due to this here? Fourth part. Answer
3
me.
mu naught I by 8r.
Yes. You see, I know initially you will have problem. You break the complete loop into sections, because you know every section separately. See, I'm breaking here one section, second section, third section, fourth section. I will write net magnetic field at O. I will write BO vector is vector sum of magnetic field due to all 4 sections. Tell me due to which section magnetic field 0? Answer me.
B1 and B3.
1 and
B1 gone, B3 gone, over. B2. Tell me, now you find direction. Tell me B2 is inward or outward? Curl your finger in the direction of current. Curl your finger in the direction of current, right hand. Thumb is inward or outward? Thumb is inward or outward? Or B2 B2 the outward. Answers below.
Inward,
Correct
sir.
answer you cannot see for B2. This one, this
Inward,
cut
sir.
finger, so you know it will be inward. Inward means this one. that here B2 is cross. What about fourth one? Tell me. Fourth one is what? Tell me.
Outwards.
Under finger. It is outward. Direction. If you make mistake, 50% direction. If direction, if in place of plus you wrote minus, over then. After that you calculate anything wrong only. For direction only one rule told you. Palm rule you use or right hand thumb rule for circular or straight. For circular only right hand thumb rule use. Curled finger in the direction of and thumb will give direction of made field. Inward, if current direction clockwise, thumb will be inward. Anti-clockwise, thumb will be outward. Now tell me B3 and B4 we have to find. Sorry, B2 and B4 we have to find. Tell me what is B2? What is B2?
Mu naught I by
Mu naught I by 4.
Mu naught I by semicircular bar.
4R.
What is the magnetic field? 4R.
4 also.
Huh?
8R.
8
Mu naught I by 4, but here radius is what for this? What is the radius for the this second one? Radius R or 2R?
2R, sir. Mu naught I by 8R.
Understanding here. For any question, answer will be mu naught I by 4R. Answer is for radius you will not see. For bigger loop, radius is 2R. So mu naught I by 4, and here radius is 2R. Direction here cross. For fourth one, tell me. For fourth one, what is the radius? And it is semicircular loop. What is the magnetic field? Mu naught I
by 4R.
4R dot. This is your answer. One cross, one dot. If you want here one plus minus form you write. Otherwise, this is your answer. How many of you clear with this fourth question? Small your mistake will over radius you have to see for one inner one radius R, outer one radius 2R. Fifth question we'll see who will answer. Try. Everybody will try this fifth question.
Sir,
Mu naught
Mu naught I.
into theta by 2 pi outward minus mu naught I by 2a into theta by 2 pi inward.
Okay. Break everyone. Break into sections and then calculate.
sir,
Hmm.
mu naught I by 2a into theta by 2 pi inwards and mu naught I by 2b into theta by 2 pi outward.
Okay. It's a very simple one, but Anna, you have to small thing you have to take care of. Otherwise, after knowing also everything, you'll make mistake. Tried everyone? Now see, break into sections. I told you, you can separately break into section 1, 2, 3, 4. I will write here net magnetic field. I will write. For few questions you do like this here. Don't that become scientist in first question itself. In shortcut you do. First you do few questions like this. 1 and 3. Tell me what is the magnetic field due to 1 and 3? Due to 1 and 3, what is the magnetic field? 0.
Sir.
Because you know that point lies on the axis of these. Only 2 and 4. Direction you calculate for 2 and 4. Second one direction is what? Tell me. Curl your finger in the direction of current. Thumb you see inward. So this cross. Tell me due to fourth one direction is what? Fourth direction is what?
Outward.
Dot. Outward. Now B2 we have to find. You know it is arc, Nara. For arc, what formula we discussed? Tell me. Mu naught I divided by R. What is the radius of this? A. Theta divided by 2 pi. Direction is what? Cross. Second one what? Mu naught I divided by 2b. Radius for this b given. theta divided by 2 pi. Direction is what? Dot. And here, if you want to write in terms of plus minus, if you take dot as a plus, then cross will be minus. Then you can also write here mu naught I by 2a theta by 2 pi minus plus mu naught I by 2b theta by 2 pi plus. Sometimes you can take common also in this here. Mu naught I theta divided by 4 pi, you can take common also. 1 by a minus plus 1 by b plus you will get. This is the magnetic field. Clear the? Everybody understood here? This type of questions you will find. So those who understand the all three important point what we discussed, they can answer along with the direction of magnetic field. Okay, direction is very important one. Clear?
Yes, sir.
So many questions you will find based on circular separate, straight separate, then combination of straight and circular. That also we will discuss. So this is here. Can I give you few questions homework? Will you do? Can I give you few questions
Yes, sir.
homework?
Yes, sir.
Questions
Yes,
giving
sir.
you homework. Okay. 2-3 questions giving you homework. You can work out. So we'll see question number 1 homework. How you Anna? Idli maker is there na? Like this there na idli maker. Oh sorry, reverse is there na? Reverse. Huh? Idli maker yaar.
Yes, sir.
Yes, sir.
अब this is center. This is radius r. I tried one day to make idli here, but it is not shape, not that coming circular. It is coming some rectangle and pentagon, hexagon coming. This is one question for you. Second question, you take this 4R, okay? Then calculation will be easy. 4R you take. Second question to you that second question giving you one very good question giving you. What is this? Pot or not? Pot? Huh?
Yes, sir. Yes,
New
sir.
discovery I'm doing here. So, like this is 8 years question as there. And now only that in 2-3 days back for the repeater batch. And you know how much this angle they have given? Huh? Pi by 3. This radius current I this distance given R as well as this distance is also given R only. Adisri, are you there? Understood this question?
Yes, sir.
So in part question understood or not? Third question.
Slightly understood, sir.
What is slightly in this?
Pi by 3 is confusing, sir.
What confusing?
Like we must
Sir,
use trigonometry or like that, sir.
Pi by 3 confusing. Pi by 3 is angle.
Okay, sir. No, sir. Like we must use trigonometry or like that. I heard.
No trigonometry. Where trigonometry used? Trigonometry no. Angle. This is pi by 3. So this angle you should know. This angle. That you can find.
Pi by 3.
60 degree, no, sir.
Yeah, this is 60 degrees. So this angle how much remaining? Remaining angle how?
120.
Please,
Senior most junior scientist. Huh?
300, sir.
Some are telling 120 degrees.
300, sir. That I
Is
came.
60 minus 60, 300.
Yes, sir.
So you will do. These are 3 good questions here. If you are doing all these, then package questions by seeing you will answer. This is about the first application here. Ampere circular law. Sorry, Biot-Savart law. Completed.
1 minute, sir. Right. Last question, sir. Okay, sir. Completed, sir.
Yes, write down second application now. Second application, write down magnetic field due to second application, right? B due to circular current carrying loop. B due to circular current carrying loop. Circular current carrying loop in bracket ring. Circular current carrying loop in bracket ring. Ring which is placed in YZ plane. Which is placed in YZ plane. Which is placed in YZ plane at x distance from its center along its axis. At x distance from its center along its axis. X distance from its center along its axis. Having radius r and carries current I. Having radius r and carries current I. In your board exam, only this application in syllabus.
Sir, having radius r
and carries current I. Having radius r and carries current I. Now you remember everybody. Tell me if ring placed in YZ plane along its axis, electric field we discussed or not? Yes or no?
Yes, sir.
Electric
Yes,
field
sir.
we
Yes, sir.
discussed or not? And we have you remember kqx by x square plus r square power 3 by 2 derivation we did. We have also plotted the graph. We saw at which point electric field maximum, which point electric field is 0. Okay, all these things we discussed. This also derivation is similar like which we discussed in electric field calculation. But you know, in electric field, magnetic field, two differences there. One, magnetic field is angle dependent, electric field not angle dependent, and magnetic field direction not decided by r vector, it decided by what? dl cross r vector. So because of these two different things, that magnetic field expression is different here. Okay, and derivation we will see, it's a very important one for your board point of view. 5 mark they ask this, that only this derivation is there in the your syllabus in board exam. So we will derive, and again we will prove that at center magnetic field is mu naught I by 2r only. But here you have to understand that loop placed in YZ plane. Now for this one question I want to ask you, if loop placed in YZ plane and this is the point which is along its axis x distance away. So tell me whatever points lie on the circumference and the point here and the point here, they are equidistant or any point is closer to the point here.
Equidistant.
Equidistant, sir.
This already we have discussed in that electric field calculation. Now again here also telling same, because from this many confused. First I will make the diagram of this, you will get the clarity. That here ring or current carrying loop placed in YZ plane here, YZ plane. Like this here, this placed in YZ plane. Clear na? Almost okay na? So this is the center. This placed in YZ plane and carries current I. Okay, I current it carries here. Suppose this I current it carries. Placed in YZ plane. First we have to focus on this. Placed in YZ plane here. Its axis in which direction here? Tell me. Its axis in which direction? X direction. This is the axis here. This is the x-axis. At x distance away, somewhere here, we are going to calculate the magnetic field here, x distance away. I will say that x distance away from the center. Suppose center point O, this is x distance, point P is here. What is the radius of this? Tell me here. What is the radius of this?
R.
R. It carries current. I current may be clockwise, anti-clockwise, yours. Now at P point, you know, for finding the magnetic field, we have to select the current element. Try to understand. This is the loop. This is the axis. Current going like this. Like this current going. Current element we have to choose here. Like we did in electric field calculation, dq charge we have taken here and here, symmetrical element, then we saw which element exists, which element cancelled out, vertical component cancel or horizontal component cancel, we have checked that by taking the symmetrical element. So here current flowing like this here, one element I am choosing, that current element at the highest point here and here, one element. Why I am taking 2 point here current element? To show you that which element, which component will exist and which component will cancelled out. Okay, so here what I will do, this current here, so IDL, everybody will see, I am making here current element direction, it is IDL vector like this. Try to understand why IDL vector. This is placed in YZ plane. This is placed in YZ plane. So tell me, IDL, will be towards me or not? DL direction, who will decide? Current will decide or not? DL direction, current will decide.
Yes, sir.
Flowing. The ideal always tangential towards me. I'm making ideal towards me because current flowing like this here, like this. Tell me at this point, Ra, what is current element direction? At this point, tell me current element will be somewhat like this or not? Inward it will go or not? Ra? Yes or no?
Yes, sir.
In a
Yes,
current, current coming like this.
Tangential.
And it will be one is coming towards me, one is going away from me. Okay, tangential this. Now at P point we are calculating magnetic field. This is from current element to point P. But Savatla, remember current element to point P. What distance we have taken? R we have taken or not? Yes or no?
Yes, sir. We have taken R, sir.
So here we are considering that suppose this is R vector. This is R vector. Magnitude of R vector is nothing but R only, no problem in this. What is the magnitude of R vector? Tell me. How you will calculate R? Tell me. This is 90.
Root of R
This is
square plus
Square
X
plus
square.
square plus square.
So here I write this that R is nothing but root over R square plus X. Okay, and this is R vector actually. Magnitude of R vector is this one. Magnitude of R vector is this one. Now, similarly, from this element also that you are getting that here R vector is this here. Tell me that in above and below, both triangle are congruent triangle or not? Yes or no? This is
Yes,
X.
Congruent.
This is congruent. Congruent means you tell me that if this angle is phi, so tell me this angle is also phi or not?
Yes,
or
sir.
no? Congruent
Yes, sir.
triangle. Now current element and R. Magnetic field direction, tell me who decide? Not only DL, it decided by what? DL cross R vector. Yes or no? But Savatla vector from
Yes,
this
sir.
plus direction of DV vector not decided by DL alone, not decided by R alone, decided by DL cross R. Sudarsana, are you understanding what I'm telling?
Yes, sir.
Today you not speaking where you are.
Sir, I have answered, sir.
Okay, so DL cross R. Now curl your finger from DL to R. Cross product, everyone know. A cross B equal to C. How you calculate direction of C? Curl your finger A to B. Then direction of thumb will decide direction of what? C. Here DL cross R. Everybody see DL is towards me. Try to understand. This is DL. This is R. Curl your finger from DL to R. DL to R. You will find that magnetic field will be somewhere like this. This is dB vector direction here. You tell me dB vector equal to DL cross R. So dB must be perpendicular to R or not? Yes or no? dB must be perpendicular to R vector
Yes,
or not? You are getting me? dB must be perpendicular to DL also or not? This angle, tell me how much this
Yes,
angle
sir.
should be? How much this angle should be? 90 degree or not?
90 degrees, sir. Yes, sir.
Everybody understanding this? dB must be perpendicular
got
to R because cross product. Okay. Similarly, for this element, if you see DL cross R, so here that dB vector you will get like this. You will get here. This is the dB vector. This I am showing you to check that which element cancel, which element will remain.
Okay.
This dB vector. Now, see this is X direction. If this is X direction, so tell me if I draw one perpendicular line to this X, then tell me this I will get Y axis or not? Yes or no? If
Yes,
this
sir.
is so
Yes,
tell me
sir.
this is Y axis or not? Now tell me if this angle phi, everybody will see this angle phi. So what is this angle? Use
90 minus 5.
90 minus pi.
90 minus.
Angle will be 90 minus phi. 90 minus phi. If this angle 90 minus phi, what about this angle? Tell me
5, sir.
about this angle.
Pi, sir.
Phi or not?
Bye, sir.
Because this total angle should be 90. So 90 minus pi. So this is pi. Now can you
Pi,
break
sir.
dB? Same way. You see this is pi. So if this is pi, this angle is also 90 degree only here.
Yes, sir.
DL dB perpendicular. So here if this is pi, so this is also 90 minus pi or not? This is also phi or not? Now break dB into component. Tell me dB component in this direction is what? What is the component of
dB
dB?
cos theta.
AB cos theta.
dB cos
Cos
phi.
phi.
So right, you see dB cos phi. In this direction, what component will get? Tell me.
dB sin phi.
dB
dB sin
phi. Tell me this dB component this side, what we will get? What dB component this side?
dB cos
dB
phi.
cos phi.
dB
What
dB
cos phi.
this side, what will get? Tell me.
dB sin phi.
Now tell me dB cos phi and dB cos phi up and dB cos phi down. This will cancel out or not? Yes or
Yes,
no?
sir.
Vertical component get cancelled out. Only horizontal component will be that present in the magnetic field expression. So by it is same like we discussed electric field calculation in ring. Electric field calculation in ring. There also vertical component get cancelled out. Horizontal component will add. Here also you see vertical component cancelled out. Horizontal component will add. So due to one element, what is the magnetic field horizontal direction we getting? Can we write here the net magnetic field along the x is equal to, tell me, due to one element, can we write dB sin phi? Yes or no? Due to one element,
Yes, sir.
yes direction dB sin phi. Here dB sin phi 2 we getting because of two element we have taken. Two element we have taken to show that vertical component getting cancelled out. So dB sin phi here. Now dB we have to find. dB you know Biot-Savart. What is Biot-Savart expression? Mu naught I dl sin theta divided by, see theta is angle between I, the dl and r. That's why I have not taken here phi, theta. I have taken phi so that you not confused with this. This is Biot-Savart expression 4 pi r square. This is dB. Tell me in this triangle what is the value of sin phi? Can you tell me in this triangle what is value of sin phi?
R by R.
R by small r.
Capital R by small r or not? Later on we'll put the value of the small r. This you know it is r square plus x square power 1 by 2. So here I will this here sin phi value. Sin phi value we got here capital R by small r. Now theta. Everybody see theta. Theta is angle between r vector and dl vector. Now properly see dl. dl coming towards me, I dl towards me, and r is this. One r is above the x-axis and one dl is what towards me. What is the angle between dl and r? Tell me. What is the angle between dl and r? That is 90 degree. So here this angle everybody should know. This only you can understand geometry or this three-dimensional geometry. Here this angle will be similarly this angle will be what? 90 degree here. Theta value we are getting here 90. If
90
theta
degree.
90, if you substitute here theta 90, you will get net magnetic field
1, sir.
along the x is equal to mu naught. I will write here, see mu naught
Not ideal.
sin 90 is 1 by 4 pi
Pi R square.
r square and here r by r, which I can write mu naught I
Not ideal.
r by r
Divided by
r
4
square
by
what I can
r
write?
cube.
It will be r cube. Okay. Achha. This is here that due to one element. Now we have to calculate the total magnetic field. What we will do? Tell me total magnetic field. I have to find
Integration.
Integration.
We'll integrate this integral dB net x. Now tell me what is variable in this? What is constant that you take outside? Mu naught 4 pi constant or not? Can we take outside?
Current constant.
Same
Current
current is flowing everywhere. Radius is also same here r constant r cube. At a particular point p, that x is also same. At a particular point p, that x is constant, so r cube integral dl. Only L is variable. Now tell me, due to one element we calculated this much magnetic field. Like this ideal element, if you break here that into infinite part, tell me dl, if you add what you will get total? What is the integration of dl? L you will get.
L.
What is the length of the circular wire?
2 pi R.
2 pi r.
2 pi R.
So here you will get that integral dl. Here integral dl is nothing but L, which is equal to 2 pi r. If you substitute here, you will get net magnetic field in x direction is equal to mu naught I into r into integral dl value. integral dl value substituting here 2 pi r divided by 4 pi into r cube. Tell me here 2 pi cancel with this one. R into R, you know, R square. Mu naught I R square divided by 2. R cube. What is R cube value? Ra? What is R cube? Tell me what is R value? R value we have written something in above.
R square
Tell me,
plus
can we
X
write
square
R
power
square plus R square
2
power 1 by 2?
R square
Right? Plus X square power 1 by 2 or root over. So tell me if I write here this, I will get the expression mu naught I into R square divided by 2. Tell me R value. What R value? Ra? R square plus X square
Root
power 1 by 2.
3
4
by
power 3 is there or not? Ra?
3 by 2,
4
sir.
power 3 is there or not? So 3 will multiply with this. You will get what? 3 by 2. So here we are getting finally mu naught I R square divided by 2 R square plus X square power 3 by 2. This is net magnetic field along the X. In vector form if you write, so it will be mu naught I R square by 2 R square plus X square power 3 by 2 I cap. And if you write in scalar form, only magnitude form. So what we getting magnitude? Magnitude what we getting? Mu naught I R square divided by 2 R square.
R square plus X square power 3 by 2.
Clear? Everybody understood this derivation?
Understood, sir.
Note it down.
Yes, sir.
Proper diagram this. Here in diagram everything. No.
Wrote, sir.
Wait. Let others to write. Completed everybody?
Yes, sir.
Completed.
1 minute.
Sir, direction of ideal alone, one second.
Sir, zoom the diagram, sir.
I will. What? I will tell
Zoom
first
the
complete
diagram, sir.
the diagram. This is placed in YZ plane. This you consider your thumb, that your hand that is in YZ plane, and this is the x-axis here. Current flowing here in your hand like this in outer one. Now tell me current element how in which direction it will take. At highest point current element in which direction will come. Tell me it will come towards me or not, that at highest point current element.
Towards
Sir.
And at this point how current element will go? It will go inward like this. Getting this three-dimensional structure, I can tell you like this only. Here you have to feel this, that yeah, 3 dimension. Clear up to this completed?
Yes, sir.
Yes, sir. Completed.
Completed, sir.
Those who completed can leave. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
1
Thank you, sir.
minute, sir. Writing, sir.
Yeah, you right. Those who completed, I'm telling, can leave. Thank you.
Thank you, sir.
Thank you.
Sir, after this, show fourth and fifth question, sir.
Okay, just a minute. Everybody completed? Everybody completed this?
Yes, sir.
Completed, sir.
Okay. Thank you. Yeah, 4 and 5 question you are asking here. 4 and 5 question.
Yes, sir.
Yes. 4 and 5. This is 4 and this is 5. Yeah. Okay.
Sir,
Thank you, sir.
Yeah, thank you.
sir,
Yeah, tell me which. Thank you.
sir, that question I will say it now, sir. Theory only, sir.
Yeah.
Sir, that in the capacitor in between the plates, the distance is increased, sir.
Hmm.
And at that time, the battery is disconnected, sir.
Hmm.
So, in the options they gave, we should find which quantity remains unchanged, sir.
Hmm.
And the options are potential difference, charge, and both of them, and none of those, sir.
Hmm.
I chose charge, sir, because charge remains constant, and we disconnect the battery and connect it again, it will be remaining constant, sir. But in the answer, it was given that both of them would be remaining constant, sir.
Mute first. Aja, tell me what question read again? Question read. Question read.
Question not having, sir, but what is there, I know, sir.
Half question you telling Subicha. If you have question, you tell me. You send me now. I will tell.
You must switch on my system. Yes, sir.
Yeah. If question, see here, initial charge. Definitely charge remain constant. Potential may or may not. It depends on the values here. Okay. Initially you see you will write C into V, right? Initially C into V. If suppose or whatever. Suppose initially they have given some dielectric. They have given so Kc into V. Finally, if they're telling that capacitance is, finally if they're telling, see, initially dielectric is there. Try to understand, okay? This is K, C is the capacitance. If they tell now distance is decreased, so tell me, suppose K value is 2 or something, huh? If K value is 2 given, just for understanding, that the K value given 2, initially capacitance 2C into V is the charge. If now distance increased to double, so what about the new capacitance? Tell me. New capacitance will become C by 2 or not? New capacitance will become what? C by 2. Okay. Or that here it depends on the question whether C initially A epsilon. Now if dielectric also they remove. If dielectric also they remove. Okay. Or that new dielectric inserted. Suppose this dielectric constant 4. If new dielectric inserted, so tell me new potential what you will get now? It will be same or not? V dash will be V or not? Getting?
Oh, yes, sir. Yes, sir.
It depends on that what they giving in question. Okay, charge always remain constant. From charge conservation, you will find the potential whether constant or not. Getting? If that initially different dielectric is there, finally after disconnecting different dielectric is there, distance also increase. So capacitance changing here, and based on that potential may not change. Potential may not change also. Understood?